Morning, YouTubers. I'm teaching Codesters these days as a virtual teacher, and this is not the lesson I'm going to do today remotely, but it's the kind of thing I'm into. We're talking here, you can see my final result already. We're talking here about triangular numbers. Here's two points. Number one, when you're learning to code, it's not about turning off your imagination, it's about ramping it up, turning it up a notch. Just like when we learn to read, they give us picture books when we're young, and that helps us understand what we're reading, and then the pictures there are fewer and fewer of them, usually. We get to read novels that have no pictures at all. And the thinking here is not that you're slowly losing your ability to imagine, but that you are less reliant on pictures that other people have drawn and you're able to imagine yourself. So you're creating your own mental imagery as you read, and this is a sign that you're a strong reader because you have a rich mental life, imaginative. You can see what you're reading about, like that. So a lot of novels, they'll spend a lot of time on a description. They're trying to, engage you in imagining that landscape. They're telling you about the flowers and the trees. So if you don't know the names of species and stuff very well, those kind of long descriptions can get kind of boring and you skim over them because that's a talent you may have not acquired. Because as culture changes, what we imagine, what we can imagine changes. In this day and age, architecture, design work, CAD, sculpture, art, there's always going to be a need to be able to visualize like spatial geometry, like this kind of stuff I'm showing here. And so I'm holding flextegrity, which is just cube-centered packing, CCP, but without all the nodes actually touching. So it's not like it doesn't have a density of 0.74. It has a much lower density because of all the empty space between the compression units. Okay, so that makes it good for didactic purposes, pedagogy, and so forth. Today, though, triangular numbers is what I want to look at because point number two, my first point was you want imagination. My second point is as you access STEM topics like spatial geometry, you don't need to start with coordinate systems. Finding a unique address for every point in space, X, Y, Z, and stuff like that, that's coming, that's useful, but that doesn't have to be your starting point. Your starting point could be more like in the Book of Numbers by Conway and Guy, which I highly recommend. It takes exactly this approach of figurate numbers, which can become polyhedral numbers. In other words, triangular numbers on a flat plane is what we're looking at here. And in the curriculum I favor, I teach about the Bucky Fuller stuff. We have this term frequency, which refers to the number of intervals between spheres. So 1, 2, 3, 4 frequency is equivalent to a triangle that has 1, 2, 3, 4, 5 balls on an edge. Usually when you see these formulae for the number of spheres, like let's go to the online encyclopedia of integer sequences and just type in a first set of triangular numbers. So it's 1, 3, 6, 15, 10, 15, right? That's the beginning of this sequence. And that takes me to the triangular numbers here. And then there's all kinds of information on that. But they use n, meaning the number of balls on the side, not the number of intervals. So when I jump into Codesters and write this little program, I accept frequency, the number of intervals, as my inputs. But what I do is I bump it up to the number of balls on an edge by just going n equals f plus 1. So then my results agree with everyone else's. When I hit enter, there's the triangular number sequence. You can read about it in, of course, Wikipedia. There's tons of information there. about triangular numbers, and it introduces sigma notation. And if you're not familiar with sigma notation, this is a good way to connect your learning to code work with traditional conventional mathematical notation, sigma being a summation sign. And as the gradations between what we're summing become ever slimmer, in other words, we are moving in the direction of infinitely tiny time slices, for example, like when we make a movie with an infinitely fast camera that can take zillions of frames per second, then we're getting into the calculus area, and they change the sigma to a Riemann sum, which is also for summation, a symbol for summation, but its curvaceousness reminds us of the continuous nature of what we're summing. You can use it as a mnemonic. The fact that a Riemann sum symbol is a tall, lazy S compared to a sigma, which is kind of jaggy, that's kind of a symbol of discrete versus continuous math, just using the imagination there a little more. All right, so when I run this, as you can see, the output's already here on the side, and 1, 3, 6, it is the triangular numbers as we would expect. 0 missing, but we could add that in. And all right, that's good approach. Imagination and figurate polyhedral numbers with even simple tools like Codesters, which are free and in the cloud, so you don't have to have anything on your computer other than Wi-Fi for this to work. All right, talk to you soon.